Okay, we are recording. So I'm going to start with a small lecture on what is subnetting, and then we will do exercise today and on Thursday also. So I'm just going to present why we need to do subnetting and how to do it. So one of the reasons is that some protocol in IP use extensively broadcast. And broadcast is not something that we like because we send a message to all the devices. And all the devices have to process this message. And sometimes we just want to reach a specific device, but we don't have all the means, and we need to send a broadcast. For example, if you look at these two protocols, the address resolution protocol is a protocol that will allow you to resolve an IP address to a MAC address. This protocol make extensive use of broadcasts. And there is another protocol, which is dynamic host configuration protocol. We already talked about DHCP. It's also make use extensively of broadcasts. So if we have a big broadcast domain, it's negative. It impact negatively the computer because it will slow down our network. So as we can see here, it says negative because it slows down the network, and it's forced that all the devices that belong to the same broadcast domain have to process the broadcast packets. So one idea is, let's say that you have a company, and at the beginning, you set up only one network, and you have 400 employees. So they will be connected here. The computer will be connected to switch here. One computer of the 400 computers send a broadcast, it will arrive in the other 399 computer. And the other 399 computer will have to process the broadcast, even if it's not for them. So instead of maintaining a big broadcast domain, what you can do is to separate the broadcast domain in smaller broadcast domains. For example, here, we decided to divide the 400 employee into group of 200. So we will have here one local area network on this interface of the router and another local area network in the other interface of the router. So one of the characteristics of a router is filter the broadcast, which means that if a broadcast arrives to a router, it will never forward it, which means that in this case, let's say that of the 200 user here, one user send a broadcast. Only 199 will receive the broadcast, but not like in this case, like 399 users were receiving the broadcast. So you are making the broadcast domain a little smaller, and you are making the network faster. So it's a reason why we need to create subnetwork. So there is different way to create subnetwork. So one first way is with the geographical location. Let's say that your company have a building of several floors. You can decide, for example, all the people that are in the first floor will be in one local area network. All the people that are in the second floor will be in a different local area network. And you assign to each floor of the building a different local area network. This is the first division. It's a geographical division. Another division is by the function of the employees. So you have several departments in your company. So for example, you have people that work doing accounting, and you put all the people that do accounting in one local area network. You are people that do document paperwork at the level of human resources. You put these people in the same local area network. The administrative people in another local area network. And let's say it's a university, you can put all the professors in the local area network and all the students in another local area network. So you divide them by their function. Another possibility to divide a big network into smaller network is by the function of each device. For example, here, as you can see, the company decided to put all the server of the company in one area local network. All the printers in another local area network. And for example, all the desktop where people are working on them in a third local area network. So the division that you choose will depend on what your company is doing, what is important for you. And of course, you can do also something hybrid. You take idea of geographical location with, for example, what the person is doing, what is the job of the person. This is what most of the company will do. They will do a hybrid scheme. So when we are going to do subnet, we are going to borrow bit of the host part and convert those bits to network part. So last time we talked about class A, class B, and class C IP addresses. And we say that, for example, a class A network have 8 bits that are dedicated to the network and 24 bits that are dedicated to the host part. You remember? We talk about where we will break the IP address in two. The left part will be the network part and the right part will be the host part. So the net mask, when we have a 1 in the net mask, it indicates that the bit that the corresponding bit in the IP address is a network bit. So what you will do is that, for example, you can borrow some of those bits on the host part and convert them from a H to an N, which means from a host bit to a network bit. This is what we will do when we will create subnet. So for example, here, as you can see, I can, for example, borrow 1 bit and change it from an H to an N, or I can borrow 2 bits. Change these 2 host bits into an N bit, or I can borrow 3 bits, 4, 5, 6. It depends on what I want to do, how many subnet I want to create, and the size of each subnet. No? So when you create subnetting, for most of the people, it's much easier to understand if the boundary is between 2 bytes. But if the boundary is within 1 byte, some people have some problem to understand it. So I'm going to start explaining when the boundary is between 2 bytes. Let's say that your initial network is a class A network, and it's the network 10.0.0.0/8. So this /8 say that 8 bits are dedicated to the network portion. So when I represent the pattern of bits, I will put 8N, saying that all these bits belong to the network portion, and 24 bits belong to the host portion. Now, you may borrow, for example, when you create your subnet, you may borrow these 8 bits and change them to the network bits, which means that the boundary, the initial boundary is here between the network part and the host part. You may run it up to here. So you borrow 8 bits from the host part and convert them into a network bit. So when you borrow 8 bits, you can create 256 subnets, because if I borrow this bit, I have 2 possibilities, 0 and 1. If I borrow this bit, I have another 2 possibility. Here I have another 2 possibility. Up to here, I will have 2 possibility. So 2 times 2 times 2 times 2, 8 times, will give me 2 to the power of 8. And 2 to the power of 8 is 256. So I will be able to create 256 subnets. And each subnet will have 16 bits to manage the host portion. So the total number of IP addresses will be 2 to the power of 16. 2 to the power of 16 is 65,536. And since we always lose 2 bits, 2 IP address, sorry, in the network, the first IP address on the last IP address, the number of valid IP address will be 65,534. So look what will happen. The initial pattern is this pattern. 8-bit for the network part, 24-bit for the host part. So I'm going to borrow those 8 bits and convert them into network bits. So we use, instead of saying that there will be network bits, we say that there will be subnet bits. So here in the pattern, instead of putting N, I'm going to put S for subnet. So these 8 bits will belong to the network part. These 8 bits will belong to the subnet part, and this 16 bit will belong to the host part. Okay, this 16 bit will belong to the host part. Let me show you a second example. We are still starting with this network, the 10.0.0.0/8. But this time, instead of borrowing 8 bits, we are going to borrow 16 bits. All those 16 bits. So if you look, the initial pattern is this one. We have 8N and 24H. If I borrow these 16 bits and convert them into subnet bits, look at the new pattern. We will have 8N, 16S for subnet, and 8H for host bits. So when I borrow 16 bits, how many subnet I can create? So here, this S can be a 0 or a 1. So two possibilities. This S can be a 0 or 1, two possibilities. So it will be 2 times 2 times 2, and this will be 16 times because we have 16 bits that are S bits. So the number of subnet that we will be able to create will be 2 to the power 16. And 2 to the power 16 is 65,536 subnets. Now, if I ask you how many IP address we will have in each subnet, so we have to check how many, I don't know what this mouse have today. Okay, we have to check on the host part. So on the host part, as you can see, we have 8 bits. So for each H, we have two possibilities. So it will be 2 times 2 times 2, 8 times. So we will have a total of 256 IP addresses. Since we are going to lose 2 IP addresses in each subnetwork, the number of valid IP addresses will be 256 minus 2, which is 254. Okay, so explaining subnet, where the number of bits that you borrow is a multiple of 8, is very easy because the boundary between the subnet part and the host part is done at the byte level. Now, you can do something that is a little more complex. For example, let's say that we have this pattern initially, which is 25N. It's a /24, which is 24N, sorry, on 8H. So we can borrow just 1 bit. If we borrow just 1 bit, the subnet will be a /25 because we will have, in the net mask, we will have 25.1. So the subnet will be a /25. On the /25 in the dotted decimal notation is 255.255.255.128. And if you borrow just 1 bit and convert it into a S bit, how many subnets you can create? Only 2, no? You have 1 bit. So with 1 bit, you have 2 possibilities. The bit can be 0 or it can be 1. Now let's say that you borrow 2 bits. If you borrow 2 bits on the H part and convert them in subnet bits. So first, the new subnet mask will be a /26, saying that we have 26 bits dedicated to the network and subnet part. And here, since you have 2 bits, to manage your subnet. What can we say? How many subnet can we create with 2 bits? 4. So we will have subnet 00, subnet 01, subnet 10, and subnet 11. We can create 4 subnets. Now, if I ask you in each subnet, how many IP address in total we will have? How do we compute that in each subnet? I want to know the total number of IP addresses that I will have. So I look at the host part. This H gives me 2 possibilities. Time 2 possibility, time 2 possibility, time 2, time 2, time 2. So it will be 2 to the power of 6. And 2 to the power of 6 is 64. That will be the total number of IP addresses. But remember that we lose 2 IP addresses all the time. The first IP address and the last IP address. So 64 minus 2 will be 62. And 62 will be the number of valid IP addresses, or usable IP addresses, or host IP addresses, no? Let's see a third example. Let's say that instead of borrowing 2 bits, we borrow 3 bits. So look at, in the net mask, we will have how many 1? 27. So the net mask will be a /27. In the dotted decimal notation is 255, 255, 255 to 24. If we have 3 bits, how many subnet can we create? 8, which is 2 to the power of 3, no? So here, with this bit, we have 2 possibilities. Time 2 possibility with this bit, time 2 possibility with this bit. So it's 2 to the power 3, and 2 to the power 3 is 8 different subnets. So what can I say? If I create 8 different subnets, the first subnet will be the subnet 000, because I have 3 bits. The second subnet will be the subnet 001. Then we will have the subnet 010. Then we will have the subnet 011. Then we will have the subnet 100. Then 101. Then 110. And finally, the last subnet will be 111. Okay, because we have 3 bits. And with 3 bits, we can do 8 different combinations. So if I ask you in each subnet, how many IP address you will have in total? So you look at the number of H that we have. So for this first H, 2 possibility. Time 2 possibility of this H. Time 2 possibility, time 2 possibility, time 2 possibility. So it will be 2 to the power of 5. And 2 to the power of 5 is 32 bit to 32 IP address in total. Since I'm going to lose the first IP address and the last IP address, 32 minus 2 will be 30. And 30 is the number of valid IP addresses, or usable IP addresses, or host IP addresses, no? So we can borrow 4, or we can borrow 5 bits, or we can borrow 6 bits. So the number of bits that we are going to borrow depend on our requirement, as I was telling you, no? How many subnet I need, and what size the subnet need to have. So let's do an example. Let's do a first example with a lot of details. Let's say that my initial network is this network. This is a class C network. 192.168.1.0. How many IP address I have in this network? The original network in total. So if we have 24 bits dedicated to the network part, how many bits are dedicated to the host part? It will be 32 minus 24. And 32 minus 24 is 8. So I have 8 bits dedicated to the host part, no? 2 to the power of 8, 256. So the initial network have 256 IP addresses. Now, if I'm going to split these 256 IP addresses into subnetworks of the same size, each of the two subnetworks must have 128 IP addresses, isn't it? Because if you divide 256 by 2, it will give you 128. So look what will happen. If I want to create two subnets, I need to borrow just one bit. So look at 192 in binary, 168 in binary, 1 in binary. All these, I cannot change them because they belong to the network part. Now, in the host part, initially, we did have 8 bits of hosts, H, 8 times. I'm going to borrow this bit and convert this bit, which was initially a host bit. I'm going to convert it in a subnet bit, which means that I'm going to go from a /24 to a new subnet, which is a /25, saying that the first 25 bits will identify the network portion. So instead of putting an N here, we put an S, saying that this is a subnet bit. If you have just one bit to create subnet, you can create two subnets. You put, when the first subnet, it will be by changing this S in 0. And the second subnet will be by putting in this S1. So here, we are going to talk about the first subnet, which is subnet number 0. And how do I get subnet number 0? I change this bit S in 0. So if I change this bit S in 0, all the IP addresses in this subnet will have this bit in 0. So as you can see here, we put this bit in 0 all the time because it's subnet 0. So there are 4 IP addresses in a network that they will ask you to determine. So the first one will be the network address. How do I get the network address? We saw that in a slide in the last class. How can I get the network address? So you change all the host bits in 0. You see all the host bits, I have 7 host bits, I change them in 0. So if I pass this binary number into decimal, what will be this number? It will be 0. So the network address will be 192.168.1.0, which is the first IP address of the network. Now, let's talk about the broadcast address. How do we get the broadcast address? We change all the host bits. We have 7 host bits. We change them to 1. So if here I'm computing the broadcast address in the last row. If I change all of them to 1, I will get this number. What is this number? 127. So remember, we say that we started with a network that have 256 IP addresses that go from .0 to .255. And we split it in 2. And each subnet will have 128 IP addresses. So here we are talking about the first subnet. And as you can see, it goes from .0 to .127, which is exactly half of it. Okay? So remember, the network address is the first IP address of the network. And the broadcast address is the last IP address of the network. Okay, now we need to talk about the usable IP addresses, or the valid IP addresses, or the host IP addresses. How do I get the first usable IP address? So we change all the host bits into 0, except the last one. So if you look here, the first valid IP address, we have 7 host bits. I put all of them in 0 except the very last one. And if you like this number, what is this number? 1. So the first valid IP address will be 192.168.1.1. Now the last valid IP address. How do I get the last valid IP address? I change all the host bits. We have 7 host bits in 1, but the last one. So look at here. I put all the host bits, which are 7, in 1, but the last one have to be in 0. If you convert this number from binary to decimal, this number will be what? 126, exactly. So the valid IP addresses go from .1 to .126. Of course, remember that we lose 2 IP addresses. The first one, in this case, is .0. And the last one, which is .127. So the first IP address is the one that comes after this one. If this one is .0, the first valid IP address will be .1. So .1, .2, .3, blah, 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 up to .126 are valid IP addresses. And of course, .126 is one IP address before the last one, which is .127. Remember, the first one and the last one, I cannot use them to put them in a computer. Okay? Okay, that's the information of the first subnet. So you can imagine that the range of IP address at the beginning go from .0 to .255. The first subnetwork go from .0 to 127. What should the second subnetwork be? Where should it start? In 128 and end in 255, correct, because half of them, which will be the first half, will be the subnetwork. And the other half of them, which is the second half, will be the second subnetwork. So let's talk about the second subnetwork now. I changed the slides, no? So to have the second subnetwork, this bit, which is the S bit, I will put it all the time in 1 because I'm in the second subnetwork. So if I ask you in the second subnetwork, compute the network address. So for that, all the host bits, you will put them in 0. The 7 host bits, you put them in 0. And if you convert this number from binary to decimal, what is this number? 128. Of course, the previous network ended in 127. So the next subnetwork have to start in 128, and it does start at 128. Now let's see where it ends, which is the broadcast address. How do I get the broadcast address? I change all the host bits into 1. So you see here we have 7 host bits. Let me put 7.1. If I convert this binary number to decimal, I will have 255. So the second subnetwork go from 128 to 255. This is the second half of the IP address in the original network, no? Now, if I ask you what is the first valid IP address, how do you get it? You take this host part, you put all of them in 0 except the last host bit. So I put all of them in 0 except the last one. So what is this number? 129. It's 128 plus 1, 129. So of course, if this one is 128, the first valid is one IP address after 128. It has to be 129. Now the last valid IP address. How do I get the last valid IP address? I change all the host bits into 1, except the very last bit. So look, We have 7 bits here. I put the 7 bit in one, except the very last one. If you look at this number, what is this number? 254. It's one IP address before 255, which is the broadcast address. Okay? So initially we have 256 IP address, and we cut it in 2 subnetworks. The first subnetwork go from .0 to .127, and the second subnetwork go from .128 to .255. Okay, which is fair, no? Half for each subnet. Okay. Now let's say that my initial network is this one: 192.168.103.0/24. This is a class C network. In my initial network, how many IP addresses I have? How many IP addresses? So how many host bits we have in the initial network? No, we don't have 6. No, it's a 4/24. So 4/24 mean what? That we have 24 network bits. Since an IP address have always 32 bits, how many bits are left? 8, which is 32 minus 24. So if we have 8 bits for the host part, and each bit gives us 2 possibilities, 0, 1. So it will be 2 times 2 times 2, blah, blah, blah. And we will have 2 to the power of 8. 2 to the power of 8 gives us 256, which means that the initial network have 256 IP addresses. And they go from .0 to .255, isn't it? From .0 to .255, we have 256 IP addresses. Now, let's say that I want to create 4 subnetworks. What will be the size of each subnetwork? If you have initially 256 IP addresses, and you are going to divide it in 4 subnetworks. Exactly. Each subnetwork needs to have 64 IP addresses. So the first subnetwork should go from where to where? From .0 to .63, isn't it? From .0 to .63, we have 64 IP addresses. The second subnetwork will go from where to where? So .64 to .127. The third subnetwork will go from .128 to .191. And the last subnetwork will go from .192 to .255. So we should see that when we go to binary. So let's see it. So look at the initial pattern is this one. Before I do subnetting, I have 24 bits for the network part, /24, and 8 bits for the host part. I'm going to borrow 2 bits. So these 2H, I'm going to change them in subnet bits. So I will go from a 255.255.255.0 subnet to a 255.192. 192 have 2 1. Okay? I will go from a 4/24 to a 4/26 because I borrowed 2 bits. So this SS, 2 bits, can have 4 different values: 00, 01, 10, and 11. So if you look at this slide, these slides talk about when we put these 2 bits in 00. If you look at the next slide, it say, okay, we put this 2-bit in 0, 1, which is the second subnetwork. If you look at the next slide, we put these 2 bits in 1, 0, which is the third network, subnetwork, I should say. And if you look at this slide, we put these 2 bits in 1, 1, which is the fourth subnetwork. So let me go back to the first subnetwork. So the first subnetwork, we have these 2 bits in 0, 0. So everything that I will talk, these 2 bits have to be in 0, 0, because we are in the first subnetwork. So we need to determine the network address, the broadcast address, the first valid IP address, the last valid IP address. So how do I get the network address? All the host bits, how many host bits we have here? 6. All these 6 bits, I put them in 0. If you put all of them in 0, what will be this number? It will be .0. So it does start in .0. Now, if I want the broadcast address, the broadcast address is the last one of the subnet. What should I do? I put all the host bits, which are 6 bits, in 1. So look here, if you put these 6 bits in 1, what will be this number? 63. So I go from .0 to .63. And of course, the first valid have to be one IP address after .0. What will be one IP address after .0? .1, isn't it? And the last valid IP address should be one IP address before the broadcast address. So the broadcast address is .63. What is one IP address before .63? It will be .62. So the valid IP address go from .1 to .62. We have 62 valid IP addresses. So how do you get this .1? Another way to get it. You change all the host byte to 0, except the very last bit. So if I take these 6 bits and I change them all in 0, except the very last one, this will what I will get in binary, and this is .1. And how do you get the last valid IP address? You change all the host bits into 1. So all these 5 bits into 1, except the very last one. So if I change all the 6 host bits into 1, except the very last one, I will get this binary number. And this binary number is .62. Okay? Let's talk about the second subnet. So in the second subnet, the SS bit, we have 2 SS bits, have to be 0, 1, as specified here. So all my calculation, I'm going to put for the SS bit 0, 1, and I cannot change them. What I can change is the host bit, but I cannot change the SS bit, and I cannot change the network bits. Only have the authorization to change the host bits. So in the second subnetwork that we already said, it have to start in 128 and end in 191. Let's verify. Sorry, it have to start in 64 and end in 127. Let's verify that. So if I ask you to compute the network address, how do we compute that? We change all the host bits into 0. So here we have 6 host bits. If I change all of them into 0, I will get this number in binary. And this number is 64. So yes, it does start in 64. Now let's verify that it's end in 127. So how do I get the last IP address, which is the broadcast address? I change all the host bits to 1. So if I change this 6 bits to 1, this will be the binary number that I will get. And this binary number is 127. So I go from .64 to 127. Now, of course, this guy has to be one IP address after .64. After .64, we have .65. It should be .65. How do we get it? We show that it's .65. So the first valid IP address, we change all the host bits to 0 except the very last one. So here we have 6 host bits. So we are going to change them all of 0 except the very last one. And if you look at this number is 65. And that's correct. It's one IP address after 64. And the last valid IP address, how we get it? We change all the host bits to 1 except the very last one. So if I change the 6 host bit to 1 except the very last one, I will get this number. And this number is 126. Is it okay? So you can do the same thing for the third network. Or for example, let me just do it one more time for the last of the 4 subnetwork. So the last one should start in 192 and end in 255. So let's verify that. If I'm talking about the last subnetwork, the 2 SS bits must be 11. So all my calculation in these 2 SS bits, S for subnet, so subnet bits, they will be in 11. So how do I compute my network address? I put these 6 host bits in 0. And if you look this number is 192. So it does start in 192. How do I compute the broadcast address, which is the last IP address? I change all the host bits, the 6 bits, I change them to 1. If I change them to 1, I get this binary number. And this binary number is 255. So the valid will go from, since this is 192, after 192 we have 193. So this have to be 193. And since this is 255, this have to be 254. So the valid go from 193 to 254. Okay? Okay. That's it. At the part of the theory that I wanted to see today with you. Let's now start doing some exercises. So in Canvas, you will have the exercises that we are going to do. We are going to start with exercise 1. Okay, so convert the following IP address to the binary equivalent. Okay, the first will show an example of how the table should be complete. So for example, if you give me this IP address, which is in dotted decimal representation, so 192 is 11 and 60, it is there. 168 is 128 plus 32 plus 8. Okay, 128 plus 32 is 160, and 160 plus 8 is 168. This 10 is 8 plus 2, and this 10 is 8 plus 2. Okay? Okay, let's say that you want to convert this one. 209.165.200.229. So what should we do? We need to convert 209 from decimal to binary. This is the first thing that we will have to do, no? So, well, we have several methods to do it. We did that at the beginning of the course. We can just use the calculator, but at least let's do it by hand one time, and then we will use the calculator. So I have 209 that I want to convert to binary. So what can I do? of 209. So one method is saying that 209 is 128 plus something. What will be this something? Plus 81, isn't it? And 81 is what? 64 plus 70, isn't it? 64 plus 17 is 81. And 17 is 16 plus 1. So what can I say about 209? 128 is there, 65 is there, 32 is not there, 16 is there, 8 is not there, 4 is not there, 2 is not in the sum, and 1 is there. That will be in binary. So I can already feel this is, in hexadecimal, this is what? This is D, and this is 1. I can memorize D1. It's cost me to memorize 1101, 0001. So I memorize D1, I go there and report D1, no? So D is 1101 and 1 is 0001. So this is the first part. Of course, we could have used our calculator to do the same thing, no? We use the calculator and ask to convert 209. So I am already in decimal. I'm going to type 209. And as you can see, it's D1, which is 1101, 0001. So we got the first part correct. And we just continue like that. No, for example, now we need to convert 165. So we could, for example, type here 165. Let me erase it first. 165. And 165 is A5. So 1010, which is A, 5 is 0, 101. Okay, so it's continue like that. Okay, this is trivial. Maybe we can do this one. Can you help with this one? It's 1, 1, 1, 0, 0, 0, 0, 0. Dot 0 is what? This is 0, 1, 2, 3, 4, 5, 6, 7, 8. And 9 is what? 1, 2, 3, 4, 8, 4, 2, 1. This will be this one. This one is not difficult to do. 17 is what? 17 is 16 plus 1, isn't it? 255 is what? Is 1, 1, 1, 1, 1, 1, 1, 1. 192 is what? 1, 1, 0, 0, 0, 0, 0, 0. And 0 is 0, 0, 0, 0, 0, 0, 0, 0. Okay? Some are very easy to convert. Okay, this is the inverse operation. They give you an IP address in the dotted binary notation, and they want you to put it in the dotted decimal notation. So let's start with this one. This one is what? The first byte is 192 plus 64. What is 192? The first byte is 128 plus 64. It will give me 192. 192 plus 2 is 194. 194 plus 1 is 195. So the first byte is 195, isn't it? What is the second byte? 0. So 195, 0. What is the third byte? 255. And what is the last byte? So it will be 128 plus 64 is 192. 192 plus 8 is 200. And 200 plus 2 is 202. Okay, isn't it? Do you agree with that? Okay, look at what they ask now. They ask to specify the class of the IP address. So what class is this IP address?
Class C.
Correct, class C. Why? Correct, very good. So remember, let me make a reminder on that. If I am a class A, what can I say about the first byte? The first byte will be between 0 and 127, isn't it? And at the level of the bit, the first bit will be a 0. So it starts by 0. This is what we know. So look, what about the class B? What do we know about the class B? The first byte will be between 128 and what? 191. And the first two bits will be 10. The first two bits will be 10. What can we say about the class C? The first byte is between 192 and 223, like they told us a few seconds ago. And what we can say about the first three bits? They will be 1, 1, 0, the first three bits. What can we say about the class D? What can we say about the class D? The first byte is between 224 and 239. Thank you. And the first 4 bits will be what? 1, 1, 1, 0. And finally, remember that class D is the broadcast class. And finally, the experimental class the first byte have to be between 240 and 255. And the first 4 bits will be 1, 1, 1, 1. So look, if you look at our first example, here 195 is the first byte. Is 195 between 0 and 127? No. Is 195 between 128 and 191? No. Is 195 here? Yes, it is here. So by looking at this first byte, we know that it's a class C. Other way to see it, look, take this first 3 bits. So if here it say, it's a class C if the first 3 bits is 110. So look at the first 3 bits, 110. So it's a class C. So we can see it when it is in the dotted decimal notation, and we can see it also when it is in the binary, when it is in the dotted binary notation. So here what we have to look is the first byte. And here what we have to look is the very first bit. In this case, the first 3 bits. Okay, since the first 3 bits are 110, we know that it's a class C. So the class is a class C. Okay, let's do another example. So this is what? 128 plus 8. It will be what? 136. 136 plus 2, 138. And 138 plus 1, 139. So this is 139. Dot. What about this one? So 128 plus 64 is 192. 192 plus 32, 224. 224 plus 4, 228. 228 plus 2, 230. 230 plus 1, 231, no? So 231. What about this one? 128 plus 4, 132. And 132 plus 1, 133. So this will be 133. And the last one will just be 4. What class is this? So I can look at this number. This number is between what and what? Exactly, between 128 and 191. So when it's between 128 and 191, what we can say? It's B. Another way to see it, we take the very first 2 bits. When the very first 2 bits is 1, 0, it's a class B. Look at here. When the very first 2 bits is 1, 0, it's a class B. Okay? Let's do this example, the next one. So the next one we have 8 plus 1. 8 plus 1 is 9. Then we have what? 32 plus 16, 48. 48 plus 2, 50. 50 plus 1, 51. Then we have what? 64 plus 2, 66. Plus 1, 67, no? And we just have what? 16. Okay, so what is the class? We look at, for example, here, this value is between 0 and 127. One is between 0 and 127, we have a class A. Another way to see it, we just take the very first bit. And if the very first bit is a 0, it's a class A. Look here, it's a, if the very first bit is a 0, it's a class A. It's the only one that have the very first bit in 0. So it cannot be a class B, because if it's a class B, the first 2 bits have to be in 1, 0. And this is not the case. It cannot be a class C, because a class C, the first 3 bits will be 1, 1, 0. And we don't have 1, 1, 0 here. Okay, so there is only one possibility, which is a class A. The first bit have to be a 0, the most significant bit. Okay? Well, to determine the class, we just need, for example, here, I can determine the class without converting to the dotted decimal notation. What will be the class here? It will be B. Why? Because it starts with 1, 0. Something that starts with 1, 0 is class B. So if you convert this byte, it has to be between 128 and 191. What about this one? It will be class A, B, C, D, or E. So yes, C. Because the first 3 bits are 1, 1, 0. So this is a class C. So you see, if I have it in binary, I don't even need to put it in dotted decimal notation. I just look at the first bit of the first byte, and I can determine the class. Okay? Exercise 3. Classify the following IP addresses. That is, for each IP address, you should specify if the address corresponds to a class A, B, C address, a multiclass address, or an experimental address. So the way to do this exercise is just to look the first byte. So this is what? A. So let's put an A here. This is what?
It has to be less than. Equal to 55, it has to be less than 50.
No. The range This is multicast because between 224 and 239. 224 and 239, it will be a multicast. This is a multicast address, which is class D. What about this one? Just look at the range. We have the range 0, 127, then 128, 191. Class B, because it's between 128 and 191.
How did you know B was a multi-class address?
Because the first byte is between 224 and 239.
So if it's class D, or if it's class D and above, it's a multi-class, or?
No. D is multicast.
Okay, so just D.
Just D.
Okay.
E is experimental.
Okay.
And A, B, C are unicast. So multicast is D. Okay, if you look at the slides that we saw last time, it will say multicast is D. And E is experimental. So this is multicast. And multicast is D. Every time that we say multicast, we are in the class is D. So this is B, no? This is a unicast address. So unicasts are A, B, and C. What about this one? A, because it is between 0 and 127. What about this one? A also. What about this one? Because it is between 192, it is 192, and 223, no? For B. What about this one? C, correct. Okay, C is between 192 and 223. So this is 222, it's just before 223, so it's a C. What about this one? B. B is between 128 and 191, okay? So you can keep doing like that, no? What about this one? E, isn't it? Experimental. Because experimental is between what and what?
Experimental?
Between 240 and 255. Okay, so it's experimental, no? We are S. We are doing S. Okay. Yeah, I jumped to another one. Okay, so let's do exercise 4. At the beginning of TCP/IP, we use the classful scheme, where the net mask can be inferred from the IP address. Analyze the table shown below and identify the network portion, the host portion for any given IP address. Okay. The first two rows are example of what you are expecting to do. So for example, if you take this IP address, you know that it's a class C, no? So you have to put class C because the first byte is between 192 and 223. If it's a class C, you know that by default a class C, that will be the net mask. You remember class C have 20 bits of network and 8 bits of host. 24 bits of network and 8 bits of host, no? So if it have 24 bits of network and 8 bits of host, it will be a /24. And a /24 in the dotted decimal notation is 255, 255, 2550. Okay? Now, they ask you to do the pattern. Show which bit is the network bit and which bit is the host bit. So capital N is 8 times small n. 3, 4, 5, 6, 7, 8. So I could have write that. But since it's going to be very large, instead of this capital N, I could have write N, saying that these 8 bits are belong to the network part. This 8 bits, 4, 5, 6, 7, 8 belong to the network part. And these 8 bits belong to the host part. So you see? So instead of putting 8h, lowercase h, we can put just one big H, saying that we have 8 bits that belong to the host part. Instead of putting 8 lowercase n, we can put a big N, a capital N. Here a capital N, and here also a capital N. So at the end, we are saying that 24 bits belong to the network part, and 8 bits belong to the host part, okay? So the network address will be 192.168.10.10. This is an IP address that I can put in a computer. It's a valid IP address, no? How do we get this network address? What should we do to get this network address? Yeah, the host part, we have to put it in 0. You are right. Another way to do it is we bitwise AND this IP address with the net mask. If you bitwise AND something with 255, what will be the result? X bitwise AND 255 will be what? Will be the same X, because 255 is 81. So 192 bitwise 255 will keep the 192. So you have the 192 here. Then in the second byte, you bitwise on 168 with 255. Every time that you bitwise on with 255, you keep the value. So you keep the 168, which is there. Then for the third byte, you are going to do a bitwise on between 10 and 255. So you are going to keep this 10. It is there. Then for the last byte, when you bitwise on with 0, the result is 0. Isn't it? So it's why this is the network address. The host portion, this is the host portion. You have to put it in 0. So if you put it in 0, of course, we will have 0. Okay, let me explain this one. 10 is between 0 and 127, so it's a class A. If it's a class A, we know that we have 8 bit for the network part and 24 bit for the host part. So look at capital N is 8 lowercase n. So 8 bit for the network part. So here we have 8 for the host part plus 8 plus 8. So how many for the host part? 24. Okay? So the net mask is 255, huh?
It's probably something that you've already talked about, but will the network / host where like NHHH, is that always going to be the case for A class?
Yeah, it's already going to be NHHH because A class, let me go back to the slides of last time. So look at class A, we say that the separation is always here, which means that the net mask is always 255,000. Class A, always. So the separation is always here, which means that you will have N, H, H, H. All those bits belong to the network part, and all those 24 bits belong to the host part, all the time for A. Let's see the B. So B doesn't want to move. Okay. So B, the separation is here. So we have 16 bits dedicated to the network part, and 16-bit dedicated to the host part. So we'll have capital N, capital N, capital H, capital H. Or see, if I use lowercase letter, it will be N, 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 and another 16H. Of course, instead of saying lowercase n, lowercase n, lowercase n 8 times, it's better to say capital N, and capital N represent 8 lowercase n, no? So a class B, the separation is always here, which means that in the net mask, we have 16.1. And if we have 16.1, the network mask in dotted decimal notation will be 255-255-00. On class C, the separation is here, which means that we have N, capital N, capital N, capital N, and capital H. It's why it's a /24, because all these 24 bits are N, network bits. And these 8 bits are host bits. Okay? So, if I do this example, we have 10 as the first byte. 10 is between 0 and 127, it's a class A. If it's a class A, the separation is done here, between the 10 and the 101. So I will have a N, H, H, H. As you saw in the slides, the mask is /8, which is 255.0.0.0. And what will be the network address associated with this IP address? So look, you are going to bitwise on this value with this value, which means that you are going to keep as it is the first byte, and the remaining 3 bytes have to be in 0. So you keep the 10, and the remaining 3 bytes have to be in 0 in the network address, isn't it? Okay, let's do this example. So what can I say about 180? It is between what and what? It is between 128 and 191, correct. So it will be what? A class B. If it is the class B, where is the separation? Where? After the 5, no? It is there, between the 5 and the 6. So what can we say? N, N, H, H, correct. By default, the slide, of course, if we have N, N, 8 plus 8, 16. So the N mask will be 255, 255, 0, 0. And this is a /16. Okay? So now, if I ask you what is the network address associated with this IP address, you have to bitwise on this IP address with the net mask. When you bitwise on with the net mask, you keep the first 2 bytes as they are, isn't it? And you put in 0 the last 2 bytes. So if I keep the first 2 bytes as they are, I will have 185. And the last 2 bytes in 0, 0, 0. So that will be the network address associated with this IP address. Is it okay? Okay, what about the next one? We have 202.0.0.0. 202 is between what and what? 192 and 223. So it will be class C. So if it is a class C, where is the separation? 24 bits, exactly. It will be here. The separation is here. On the left side, we have network portion. On the right side, we have host portion. So it will be network portion, network portion, network portion, host portion. So the net mask say network portion, host portion, host portion, host portion, which is sorry, it's not that. Network portion, network portion, network portion, host portion, which will be /24. So what is the network address associated to this IP address? So look at, when we bitwise and with that, we keep as they are the first 3 bytes, and we put in 0 the last byte. So I'm going to keep as they are the first 3 bytes. So I'm going to keep 20200. And the last byte, I'm going to put it in 0. It is already in 0. So what can I say? The IP address that you gave me, it was already the network address. Can I put this IP address in the network device? No. Remember, in the network device, you cannot put the network address and you cannot put the broadcast address. In every network, we lose 2 IP addresses. The first one, which is the network address, and the last one, which is the broadcast address. All the IP address in between the first one and the last one are valid IP address. Okay? What about this one? Class A, B, or C, or D, or E? A, because 9 is between 0 and 127. So the separation is here, okay, after the first byte. So the first byte is a network byte. Then the other 3 bytes are host bytes. So as you know, the net mask associated with a class A is 255.0.0.0. And this is a /8. Now, if I ask you what is the network address associated with this IP address, what will you do? This IP address with the net mask. And if you bitwise this IP address with the net mask, it tells you keep the first byte as it is and change the other 3 bytes to 0. So I keep the 9 as it is and the other 3 bytes in 0. This is it. This is the network 9. Class A have network 1, network 2, network 3, network 4, network 5, 6, 7, 8, 9, up to network 127. Okay? What about this one? It is what? Class A as well. So we have network, host, host, host. So we have the same network mask. So what will be the network IP address? Exactly, 100.0.0.0. I keep the first byte as it is. Okay? The left part that correspond to the network part have to be common. So if the left part is common, if we have 100 here, we need 100 here because the left part is common. Here, for example, the left part is 3 bytes. It has to be common, so I need to maintain this 3 bytes. All the IP address of this network will have this 3 bytes in common, the first 3 bytes. What about this one? Let's do this one. Start with 210. It's a C. If it's a C, it will be, the separation will be here. Okay? So it will be network, 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 host. So it will be 255, 255, 255, 0, or /24. If you bitwise on this IP address with this net mask, you keep as they are the first 3 bytes. So I'm going to keep 210, 255, and 0 as they are. 210, 255, and 0. And the last byte, I'm going to put it in 0. So I put it in 0. At the end, as you can see, this one is already the network address. So you cannot put it in a computer or in a printer or in a wireless router or in a network scanner. Okay, or if you have an IP camera at home, you cannot put this IP address in the IP camera because it's not a usable IP address. Okay, exercise 5. So it's saying, analyze the table shown below and identify the address as public or private. So this one is public or is private? So we have a slide on that. There are 3 blocks of private IP address. So the first block go from where to where? From 10.0.0.0 to 10.255.255.255. This is the first block. Then we have a second block. It's go from where to where? 172.16.0.0 to 172.31.255.255. Then we have a third block that is private. It's go from 192.168.0.0 to 192.168.255.255. So we do have a slide on that. Let me show you. It is there. So look at from 10.0.0.0 to 10.255.255.255, all of them are private. From 172.16.0.0 to 172.31.255.255, all of them are private. And from 192.168.0.0 to 192.168.255.255, they are private. So what can I say? Public or private? Correct, public. What can I say here? Private. Okay, what can I say here? Correct, private. What about this one? Correct, private. What about this one? Public. What about this one? Correct. 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 What about this one? And this one? Correct. So it's just, you need to know the range. Who is public, who is private. And people that work in networking do know the range. Okay, because it matters a lot when you configure devices, if it's public or private. Okay, look at this exercise, exercise 6. Classify the following IP addresses. That is, for each IP address, you have to specify if the address corresponds to a class A, a class B, or a class C, a multicast address which is class D, or an experimental address which is class E. They say to answer, do not convert the IP address into the dotted decimal notation. What can I say about the first one? A. Why? I just have to check the first byte. It's A. What can I say about the second one? It's multicast. Okay, so this one is A, this one is D, or multicast. So what about this one? This one is C, correct. Okay, So I just look at the first bits and I know. What about this one? A. Okay. What about this one? Experimental, correct, which is class E. Okay, this one is experimental. Experimental addresses. Okay, so what about this one? B. Okay. What about this one? Multicast, correct, which is D. This one? B, correct. What about this one? C. So of course, the first byte have to be between 192 and 223, no? And the last one is E, experimental, no? The last one is class E, experimental. Remember that multicast and experimental, we don't talk about net mask. We talk about net mask in A, B, and C, but never talk about the net mask for experimental or for multicast. If I go back to the slides, look here, they say the default mask is this one. We are in A. Here, they say the default mask is this one, which means the separation is here. We are in class B. Here in class C, the separation is here. So the default mask is this one. But when you go to class D, they don't talk about net mask. We don't have net mask associated with class D and class E. Okay? Okay. Thank you so much. I see you in next class.